In this lesson, we'll take a few minutes to introduce a type of writing in mathematics called function notation. Now, function notation is written as f of x and is equivalent to y. It is not intended to be multiplication of x and f, and is really interpreted as the value of f at x. So in the situation, we have a certain value or a certain function of activities that we are conducting to our variable x. So if I want to take a starting value x and manipulate it in some way, I can come out with f of x equals 4x minus 1. So whatever x is, I multiply it by 4 and then subtract 1. Now this would be the equivalent of simply saying y equals 4x minus 1. But when we have multiple functions happening in the same situation, and I had another one to do, I would say y equals 1/3 x plus 7. Now when I talk about them, I'd have to say, well, which y am I curious about? The way we take care of this in function notation is I'd simply say g of x equals 1/3 x plus 7. Then I could talk about the function f, or I could talk about the function g, and it becomes much more clear as to what is happening. Now we can evaluate these functions for their different x or input values simply by replacing the x in the statement with the appropriate value. Let's take a look at this. So I have functions here, f of x, negative 3x plus 5, and g of x, being x plus 2. And I want to evaluate for domain values of 4 and negative 2/3 on each function. So, in my first one, for f, when I evaluate it for 4, instead of saying f of x, I simply say f of 4 equals negative 3 times 4 plus 5. So wherever I saw an x before, I'm going to replace it with that 4. Then I evaluate. Negative 3 times 4 is negative 12. Negative 12 plus 5 is negative 7. So I have f of 4 equals negative 7. That can also be interpreted as being a point. 4 is the input, negative 7 is the output. If I try it for negative 2/3, I have f of negative 2/3, which is negative 3 times negative 2/3 plus 5. Negative 3 times negative 2/3 is simply 6. 6 plus 5 is 11. So I have another point that I can use for my graphing. How does it work on the next one? G of x equals x plus 2. So let's run g of 4. That becomes 4 plus 2, which is simply 6. If I go g of the negative 2/3, then I get a negative 2/3 plus 2. 2 minus 2/3 would be 1 and 1/3. So I have another point that I can use. So if I write a value in for x and find its output value, that becomes a point, same as finding any other coordinate. But what happens in my bottom situation here when I say if h of x equals 2x minus 3, find h of 17? So what this is saying is I know what function or what activities I'm doing to x when I call it h. I'm multiplying x by 2 and then subtracting 3. But I have now h of x equals 17. What this is asking is what x value would give me an output of 17. Well, since h of x equals both of these items, 2x minus 3 and 17, in order to find this, I simply set 2x minus 3 equal to 17, and it will help me to find the x. Using my solving methods, I'm going to add 3 to each side. I get 2x equals 20. And then if I divide both sides by 2, I come out with x equaling 10. So I can then say h of 10 equals 17, and I have the coordinate 10, 17. As you move forward in your study of mathematics, function notation becomes a lot more prevalent. You're going to see a lot more f of x, g of x, h of x than you are any other, than you'll see y equals. So it's nothing new mathematically, it's just coming to find and understand the terminology.